This is going to be fairly short. I think everybody knows what the low-level API is about. It's about portability. Portability specifically towards the interfaces of the silicon vendors, but also specific peripherals or specific manufacturing aspects that we're getting into with the OEMs and ODMs also at the moment. So I'm just quickly threw up some bullet points there. That's actually the condensed version of the two-page charter that the low-level API working group has. You know, we try to find what sort of interfaces are needed to make a middleware stack, the whole router stack, portable. We work with silicon vendors to see, well, what does their hardware look like? How should we define these interfaces? We document for the users, for the silicon vendors, how they need to implement, for the users, how do they need to use it. Verification of compliance. We just heard Tim talk about how that's going to be the next thing. We also try to align with the open source community, so we look in what did OpenWRT do, what did RDKB do, what did sometimes desktop Linux do, as we've been looking recently at something. Then we work in a realistic manner. We cannot boil the whole ocean in one day for sure. So we set a realistic goals of, okay, there's a first phase where you're allowed to do this, and then we're going to chip away at what we find acceptable until everything is all clean, standard, open source Linux interfaces, which requires us to work with the Linux kernel community. So that's a very, very long path to compliance, both from the open source side as from the vendor's side. And to put some force behind that, we work with the service providers to make sure that they put that in their RFQs, their RFPs, in their specifications to make it clear that you do need to comply at some point in time. How do we organize? Mostly there are the bi-weekly calls on Monday just before the certification working group call. What have we done in the last year? The version 1.3 of the low-level API recommendation was published. That's a while ago now already. That's added really much more realistic goals and clarified a bunch of things that were really described at a very high level in version 1.2. Things started to get implemented then as well. So we defined multiple phases for QoS, where a first phase was you can have a proprietary user space module inside the QoS manager that David just mentioned. Then that's the other way around, isn't it? Sorry. Then in the next phase, you're expected to work inside existing interfaces that exist already in traffic control in Linux. And then a third phase in the future will make sure that we align with an open source framework inside the Linux kernel where you can cleanly hook in the implementation. Phase 3 requires a lot of investigation to see how that actually works. So an implementation was done for Broadcom and by MaxLinear of phase 1. The slide is the other way around, I apologize. Meaning that there are proprietary modules in user space that can be linked into the QoS manager. MaxLinear decided to skip ahead and go straight to phase 2, so they've documented for us. I now have a co-chair, Mahipati Deshpande. I'm sorry that he's not here today. And he took it upon himself to document how the silicon vendors need to hook into the Linux kernel to find out the configuration through Linux traffic control and then apply that to the hardware, the QoS module behind their packet accelerator, typically. So they went straight to phase 2 in the implementation as well for a subset of functionality that they have. Another achievement is that there's increased uptake of the low-level API. We see increased interest. I myself, working in the RDK community, have made sure that some of the new interfaces, so some of the existing hardware abstraction layers in RDK have disappeared. New things are defined on top of standard Linux. And we're at a point also where RDK also formally advises vendors to use to be compliant with a low-level API. Specifically on wireless, that is actually crucial at this point in time. Another good thing is, we can't take complete credit for that in purple, but there is a convergence on the kernel version. So the next LTS version of Linux is 5.15. That's adopted by Android, by RDKB, by desktop Linux, and most of the silicon vendors are already migrating towards that, or are already on that, or on a path to. So we are actually very, very close to having the same kernel version for all silicon vendors, which makes innovation a lot simpler. I'll skip over some details. What do we want to do next? We definitely need to get started on a new version of the low-level API. I just put up a list of a bunch of things that we need to do. As mentioned, there are some aspects of, some of it is not just about the silicon vendor. Some of this is about the manufacturing processes. Each operator may have specific parameters that they want to set in a certain way at production time, and how you model that tends to be completely up to every individual system integrator with every individual OEM. If you're working with multiple OEMs, I'm dealing with 5 of them at the time, then this becomes very, very difficult. They all need to create manufacturing processes specifically for that. So we're trying to define exactly how that's modeled in the bootloader, in Flash, how that's also modeled in a secure manner, how that's transferred from a secure bootloader. A security working group's been working on a secure boot specification to make sure that the more sensitive components of that are handed over to Linux in a safe manner. I'll skip over the rest. New next generation carrier grade reference platforms, that's also the very big breakthrough. So far it's been very theoretical, but now we actually have reference platforms here for a max linear target. Where's the Gaon stand for a Cortina Access based platform? And is there a WNC stand here somewhere? Over there as well for a Qualcomm-based platform with the full cooperation of the silicon vendors and OEMs actually offering these, sometimes retail available, which is great. Now we actually have real platforms and a commitment from all of those vendors. That's going to be, that leads to more complexity, as in how are we going to handle these platforms? Well, what we hope to do is that we're working with all the silicon vendors from a contractual perspective so that we can host their BSPs in the purple repositories so that they can be integrated into ERCI. And anybody makes a change in, for example, Purple OS or one of the other purple components gets built automatically, and we know if the build fails for a particular platform, for a particular silicon vendor. And that also leads to the next question of something that we're going to have to resolve. What if it's broken? Who fixes it? To whom do we report a bug, as there is not really a real commercial agreement in place? That's something we need to work out. Certification, as mentioned, that's something that we're going to have to work on. And the last one is dear to me specifically, in that the wireless low-level API has been defined a long time ago. We pretty much have all the silicon vendors there or compliant or getting there. Purple Mesh actually started as a way to test and certify the low-level API compliance on wireless, but there are gaps. They're just things that we can get through proprietary interface information. We can get through proprietary interfaces that are simply not present in config 802.11, in NL 802.11. So fortunately, we've gotten to the point in Purple Mesh where we know where those gaps are. They're now identified. They're very explicit. We know what part of information we need to be able to get out there. Purple Mesh has gone to, in order to be able to deploy and to actually do something, has gone into the way where they've created a hardware abstraction layer of their own, fairly clean as we could possibly do. For a silicon vendor specific hooks, so for the silicon vendor specific changes, functionality, there, now I've got the word, to be called via proprietary APIs, but those are now very clearly identified gaps. The tricky bit is that to fix that, we need to work with the upstream host AP communities and with the Linux wireless community to make sure those things get added to config 802.11, host APD, WPA supplicant, etc. And that's it.